And now for our friends, the polar functions. So the function is r equals sine of 2 theta. And when does the derivative dr d theta equal 0? Also, find the slope of the tangent line at the pole. And the pole just means the origin. So that just means the origin. All right, so where does dr d theta equal 0? So dr d theta, the derivative of sine is cosine. And then use the chain rule, say multiply by 2. And then set that equal to 0, which means we're really just finding out where the cosine function equals 0. And the regular cosine function looks like this. This would be 2 pi, in the middle would be pi. So deja vu all over again. That means that at pi over 2, cosine equals 0. And also at 3 pi over 2. But then keep in mind that this has 2 theta, so we would then have to say 2 theta equals pi over 2. 2 theta equals 3 pi over 2. And then when you divide by 2, that means it's going to be pi over 4, and the other value would be 3 pi over 4. And then I want to graph it and see if that makes sense. Pi over 4 and 3 pi over 4. So switch over to the calculator. I will need to change the mode to polar form. And then graph the original function, which is sine of 2 theta. And take a look at the graph, and it's this 4-petaled rose. And the derivative equals 0. Well, that's when the r is at a maximum value. So that would be, this would be 1 point. Let me check it. I got pi over 4. So put pi divided by 4, and the calculator says, yep, that's exactly where you were. There's also 3 pi divided by 4. Oh, hold on, that's... Okay, so also 3 pi, okay, there's my 3 pi, divided by 4. Okay, the problem is that's only 2 out of the 4 answers, because there would be another answer over here, and there's another answer over here. So I'm glad that I checked, because my 2 answers were correct. It was that one and this one, but I still need this one. I still need 2 more answers. So then what you could do is a couple of things. One, just realize this is 1 pi over 4, then 3 pi over 4. That means that the next one would be the next odd number, 5 pi over 4. And then the next odd number would be 7 pi over 4. Or if you continued this graph out, then you would find that this point is 5 pi over 2. And then divide by 2, and you get the 5 pi over 4. And then this last one would be the 7 pi over 2, and then that would give us the 7 pi over 4. So there's the 4 places where, or 4 times, when the derivative of the r function equals 0. And then what about the pole? So that means r equals 0. So the pole means the origin, also means r equals 0. So if you set 0 equal to the sine of 2 theta, well, the sine function equals 0 when the argument equals 0, so that would mean 2 theta equals 0, and that would mean that theta equals 0. So that means that at theta equals 0, let me just test that on the graph. So if I type in just a 0, is that the origin? That is the origin. And then for the tangent line, so if you go just a little bit to the right, you could see that it would be going out like this. And if you continued this way, hopefully you can see that, well, that it's jumping around a little bit. That's just because I've got fat fingers. Let me try using the pencil. Okay, there we go. Now hopefully you can see that it goes smoothly like this. So that means that if you only look at that part, then the tangent line is going to be y equals 0. It's going to be the x-axis. So the slope of the tangent line at the pole, well, that's just going to be the x-axis, and so y equals 0.